This presentation is about the various types of parameters in the packet classification and the different types and methods in which we can classify a packet. Why do we classify packets? Firstly, to know where to send the packets and to know the source from where the packets came from. And the second one is for monitoring and regulating the traffic. Classifying the packets consists of three rules: extracting the key, and we have to query the tables for rules, and we have to take actions as per the rules. A key is usually defined by us for the system, so it can be anything. And usually the three types of keys are destination address. It can be an IP address, a MAC or a port number, and a source address. And it can also be a payload. It can be done through deep packet inspection. Rules can be executed based on three types of matching: exact match, partial match, and arbitrary match. Exact match will look for all the bits to be matched, for example, a MAC address. And partial match, for example, it's a prefix matching on IP address where key match multiple rules. Arbitrary match is, example, firewall, which cares about the arbitrary set of bits. For periodization, classification rules may intersect, and that is the need for periodization. So we'll take the example of a router and firewall. Routers periodization happens based on administrative distance, whereas for firewalls type of action, the routes are prioritized. So block actions have higher priority than forward actions. There are two main characteristics of classifiers: query time and update time. Query time, it has to be short, the faster the better, and it should be predictable, and the throughput is more important than delay. And update time, speed is not a priority, but still it has to be updated, and it needs two copies of database for a backup and update. Now let's move on to hashing. A hash function is a function which is used to map data of arbitrary size to data of known size. So a bigger value is usually mapped to a smaller value, and when a bigger value is needed to be called, it is done using a smaller value. There are a few characteristics for a good hash. It should have no hash collisions. That is, one hash should be mapped only to one bigger value, and the data retrieval should be fast, and the data retrieval should be irreversible. That is, the bigger value should not be retrieved from the smaller value. Now let's talk about accessing the memory. One such way is content addressable memory. It is often described as the opposite of random access memory because in RAM you must provide the memory address where the data is stored, whereas in CAM we perform a query for the content itself and the memory retrieves the address where the data can be found. Now let's talk about ternary CAM. They don't restrict themselves with zeros and ones, and they use don't care bits. So for while using don't care bits, they broadening the search using pattern matching. Whereas binary CAM, they perform exact match searches using only zeros and ones. Now let's have a look at the ternary CAM block diagram. We're getting the search data as 01101, and we're finding a match at 01 and 10 lines. But 01 line has one don't care bit and 10 line has two don't care bits, which means the 01 is pretty straightforward. So we're getting the match address as 01. Content addressable memory has its own pros and cons. It is much faster than RAM due to parallel processing, but it has very high power usage and very high power dissipation, which requires more hardware. And it has lower storage capacity per density, so it is used mostly in routers and switches which need very high performance. Now let's try to understand what a trie is. A trie or a prefix tree is an ordered tree data structure that is used to store an associative array where the keys are strings. So looking up keys, it is faster, but it consumes more memory. So if we trade off memory for speed, then we can go for it. Binary trie may look similar to a binary tree, whereas this is a big difference. The binary tree, the lookup time is totally dependent on the table size, whereas in a binary trie, the lookup time is bounded and is dependent on the table size. So however big the table size is, the lookup time is the same. Now, let's see how multiple trie works. We have the prefix database which contains all the addresses along with the don't care bits. The destination address begins with 1110.100. The lookup process will follow the 111 pointer in the root, and this leads to node 2 010. Since 010 has no other overleading pointers, the search terminates with P7.
created using Powtoon.